Hello again with another example related to motion in two dimension and the projectile. I have a ball kicked off the ground at 30 meters per second at an angle of 25 degrees. That's the angle of the ground. We need to find or determine or calculate the range of the ball. So I know for sure that the range is from the starting point where onto where it's landing. So that will be the range. Now the information I have the velocity of the ball, and this is the angle, which is 25 degrees. Okay. Now, as a start, let's remember that the velocity here as a vector, we can split it into two components. It will be the x1, the Vx initial, and this one will remain constant the entire motion. From the start to the end, it will be constant. And the other component, it will be the Vy, and I will call it initial because the y component, the value of it will change because we know when we get to the maximum height, the Vy will be 0. That's for sure. Now, to find the range, we know that to calculate range, we need range equal the V of the x initial, the full component, multiplied by the total time in air. So the whole time for the travel to reach the maximum height and come back again to the ground. Now, the Vx or the initial x component for the velocity, it's easy to find. It's the V cosine 25 degrees. That will be the velocity on the horizontal. However, the total time for this object or this ball to be traveling in air, we don't know. We need to calculate it. But we can take an advantage of that the maximum at the maximum height, the velocity of the y direction will be 0. So from there, I can use the kinematics equations to say that the Vy at the maximum height, here I will just write maximum height, okay, equal the Vy initial plus the gravity acceleration multiplied with the time here to reach the maximum height. Okay, all right, so we know here this is 0. Now the Vy initial, it will be the V sine the 25 degrees. Okay, and here is minus 9.8 multiplied with the time to reach the maximum height. So I can calculate this one here quickly. So I have the velocity is 30 times sine 25. And that will give me 12.7. By rearranging the formula, it will be 12.67 over 9.8, and that will be the time to reach. It's about, let's say, 1.3 seconds. Okay, once again, I will repeat that. This is the time needed to reach the maximum height for this trip. So from here, the total time of the entire trip or the entire in air will be double the time. So because the time to reach from the ground to the maximum height, it will be equal from the maximum height to go back to the ground. So I know for sure now that the range will be the V cosine 25, and that's easy to calculate, times 2t, the maximum height. So let's calculate this one again. So I have 30 cosine 25 times 2 point. That will give me total of 70 point about 7 meter. That will be the range of this kick from the starting point to the finishing point, or where it will be landed from the starting point. Okay, someone else might try another way to solve this problem because they're using another kinematics equation to help you finding the unknown to solve the range. But either way, as long as we get to the same idea or the same answer, we are fine to use different methodology or different equation, as I mentioned in the previous videos. Okay, I hope you find this video useful, and see you again with another one. Thank you.